now that we've talked about what correlation is and how to determine the strength of correlation, we're now going to look at linear regression. Unless you have a correlation coefficient of -1 or +1, you can't draw a line that hits every single point in your scatter plot. So the idea of linear regression is to find the best fit line. And that seems kind of vague, but there is an actual definition for the best fit line. The idea is that if we look at where all the points are and where the line is, and we take the vertical distance from the point to the line, we then want to square all of those distances and add them up, and we want to make that total number as small as possible. And that seems complicated, but luckily we just have some formulas that we can stick things into. Here's our formula for the slope of the line. We take the number of values times the summation of xy minus the summation of x times the summation of y, divided by the number of values times the summation of all the x values squared, minus the summation of all the x values, and then squaring. So this is almost just as bad as our formula for linear regression. But like I said before, most of the time we have a computer calculate this, so I'm not going to do any exact examples of calculating this. But we do get the basic idea. In addition to the slope, we also need the intercept of the line. So we denoted the slope by b, and I denote the y-intercept by a, and it's y bar minus bx bar. So our b is our slope, and these bars are our means. So we take the average of all the x values and the average of all the y values, and that's our y bar and x bar. So once we have our slope, our y-intercept is much, much easier to find. So while I'm not going to do any examples of actually calculating this line of best fit, it is important to see how it's used. So I'm going to do examples to show you why we might want to find this line in the first place. Here, I'm letting x be the number of grams of fat in some fast food, and y is then the calories in that same food. And we have our regression line. We have our slope 11.73 and our y-intercept 193.85. So now that we have this line, what's the point? Why do we want this line? Let's suppose we know a food has 15 grams of fat and we want to know the number of calories. Well, we can figure that out using this regression line. I know x is our grams of fat, and in this case I know that that is 15. So I can just stick that value in for x. And once we simplify this, we get 220.58. So we know that we have 200. Once we simplify this, we get 369.8. So we know that if we have some fast food with 15 grams of fat, we know that there are approximately 369.8 calories. And this is not going to be exact because our scatter plot does not have points that lie perfectly on a straight line, but it can give you a fairly good approximation. And this can go both ways. If I want to know how many grams of fat for 550 calories, well, calories is y. So this time I'm going to use 550 for y. And then once we have that, we can now just solve an equation for x. So it's slightly harder since we have to solve now, but it's not a difficult equation to solve. We'll subtract 193.85 and divide by 11.73, and we get that x is 30.36. So we can see that that's the approximate grams of fat in this particular food. We're also going to look at something called the coefficient of determination. And the coefficient of determination is going to be super easy to calculate. Once we have our correlation coefficient r, we just need to square that number, and now we have our coefficient of determination. So as long as we have our correlation coefficient, this is going to be very easy to calculate. So the coefficient of determination tells us the total variation in our y variable that can be explained by our linear model. So it tells us exactly how much of the difference we can actually explain. And that does not imply that it's going to cause each other, but it's just that we can explain it with the change. As an example, one thing that's highly correlated is the number of ice cream sales and the number of drownings per year. And our coefficient of determination is very high. That means that if we have a lot of ice cream sales, we can explain a large number of drownings. But that doesn't mean that ice cream causes drownings. There is a background variable, in this case being summertime. More people are eating ice cream and more people are swimming. So it doesn't mean that one causes the other, but it's just that we can explain why this increase or decrease happened. If I go back to my example with grams of fat and calories in fast food, I can say that R is 0.9746, which I've calculated previously. Squaring that gives us our value of R squared, which is 0.9499. So what this tells us is that 94.99% of the changes in Y can be explained by this model. So 94.99% of the changes in calories can be explained just by looking at the fat content. That doesn't mean that fat content causes calories, but there is this correlation there, and we can explain it.